This is a video to help you create a cheat sheet for the first skill test. The first skill test will cover solving linear equations, which we'll do first, solving inequalities, and then finally solving absolute value equations and inequalities. Those three skills. I'm going to start with solving linear equations. Feel free to use the front and back side of a single sheet of paper. Put anything you want on it. This will just help you to think of things to put on it. So first of all, in solving linear equations, here's the process. First step, combine like terms on the same side of equation. Second step, do inverse operations or reverse PEMDAS to isolate variable. And then finally, check. Let me give you an example, and I'm going to give you one where you get a common error. Let's see. There we go. So 2 minus 3, parentheses, x minus 4 equals 11. Okay, so first step says combine like terms. I've got to use PEMDAS for that, and distribute first. Use the parentheses. Here is the error, typically. Distribute the negative 3 to the negative 4, you get positive 12. On the homeworks, I thought things like negative 4, negative 3, and negative 12. So again, negative 3 times negative 4 is positive 12. Just watch that on the test. Now combine like terms, the 2 and the 12 gives you 14. Okay, that's the first step. Second step, inverse operations. I have addition here, so I use subtraction first, and I'm doing it reverse PEMDAS, so start with the addition subtraction. And finally, I have multiplication, so inverse operations, divide by negative 3. And I get x equals 1. That's my step 2. Final step, check. When you check, go back to the original. 2 minus 3, 1 minus 4 equals 11. 2 minus 3, 1 minus 4 is negative 3, equals 11. And this is 2 plus negative 3 times negative 3 is 9, equals 11. And it works. Okay, that's, as I said, that is right here is by far the most common error. The other common error is not to check and to see that you did an error. So make sure you do both of those. In addition to these type of problems, we will do things with variables in them. So write down a couple of the variable problems from the review or from the homework, especially any that you had difficulty with. Okay, that's solving linear equations. Now we're going to do inequalities. Inequalities. So this is greater than, less than, greater than or equal to, less than or equal to. So what is the process for those? 1, solve like an equality. Same process. I'm not going to write the process down again. With one exception, this is the one that causes errors. When you multiply or divide by a negative number, you reverse inequality direction. And I'll write, before I go on, I will write an example of that. So let's say I have negative 2x plus 7 equals to 11. Sorry, not equals. Greater than or equal to. So you solve this like an equality, which means that you combine like terms, which has already been done, and then do inverse operations, which means start with subtraction in reverse order, remember? And then I have multiplication, so I divide, inverse operations. And here is the part where you reverse the inequality. I've divided by a negative, so I reverse that to less than or equal to negative 2. And so the most common error is right there. You can check these by plugging a number, for example, less than negative 2, like 0, for example, and see that you, oh, sorry, negative 2, 0 is not less than negative 2. Negative 4, say. You can plug in negative 4, go back to the original, go negative 2, negative 4, plus 7, greater than or equal to 11. And this is 8 plus 7, or 15. And it works. And you can see by doing that, you had to reverse the direction. If I hadn't reversed it, I'd have put 0 in, for example, bigger than -2, plugged it in, and it would say 7 is bigger than 11, which isn't true. Okay, that's how you solve them first. Now, next thing you need to do is how do you graph them? To graph them, if you have a less than, or sorry, greater than or a less than, you write an open circle to start with. If you have a greater than or equal to or less than or equal to, you write a closed circle or dot. So I'll show you what you mean with this problem. First of all, just put the -2 right in the middle. This is a closed. It's less than or equal to, so put a big close there. And it's less than, so it means it goes that direction. And that's my graph. Another example of a graph, we'll do with a compound. Let's say I have my answer was this, 2 to -4. I would graph -4 and 2. X is less than 2, so open circle. It is greater than or equal to -4, closed circle. And since it's less than 2 and greater than -4, it's the stuff in between, like that. Okay, again, the only thing to remember off this on graphing, on a number line, is open circle versus closed circle. So make sure you have some examples of that. Next, interval notation. Give some examples of that. In this case, open, the open circle, you use an open bracket that looks like that. A closed circle or dot like this one, use a squared bracket or what's called a closed bracket. So let me give some examples of that. I'll do this one right here. X is less than -2. Remember that looked like this. The interval notation would be starting at -infinity, you go to -2, and you include -2, which means you need closed. Let me give you another graph. Actually, I think that one was -4 and 2. Let's use the same one. This means now you're between -4 and 2. You include -4, close bracket, and go to 2, open bracket, like so. Okay, next, in inequalities, are compound inequalities. So compound inequalities are either ands or ors. And meaning both have to be true, or meaning either have to be true. An and will typically be written as one inequality. It doesn't have to be, but it is typically done so. For example, like that. Whereas an or is written as separate ones. And you usually write an or in between. Like so. Okay, I'm going to solve both of them. In this equation, this is actually two inequalities. It's just put into one. This says 2x plus 7 is less than 11, and 2x plus 7 is greater than -3. Let me put some there, and I just line graph them. They look a little different. Okay, so how do you solve these? You think of them as two equations, and you isolate the variable by doing it with all three parts. And finally, I divide by 2. By the way, if I divide it by a negative, I have to reverse both of these, just like you would with an inequality, or an inequality, single one, because they are just two single ones put together. So x less than 2, and x greater than or equal to -5. And now I could write that as a graph, -5, 2, or interval notation, -5, 2. Oops, that should be close bracket. Includes -5. Does not include 2. So again, how do you solve? How is this different than solving a single inequality? Not much. You just have to do 3 things here, as opposed to 2. Think of it as a 3-part equation or inequality. Okay, the ors, you have to solve them each separately. That gives you x is bigger than 1, or 2x less than or equal to -4, or x less than or equal to -2. Gives you 2 parts. These graphs will look a little different. It says x is bigger than 1, and x is less than or equal to -2, like that. Now, and then let me do the interval notation and talk about it a little bit. This has 2 parts as well, the interval notation, because it's in 2 parts, the graph. you go from negative infinity to negative 2, including 2, union, start with 1 and go to infinity. So a couple things on these. Ands are typically stuff in between. So if you get something that's going out, for example, or 2 in the same direction, you've probably done something wrong. Ors are on the outside. Again, typically, not always. And therefore, their graph will have 2 parts, and their interval notation will also have 2 parts. Okay, last one, absolute values. We'll start with equations, and I'll give you an example. There we go. 2 absolute value of x plus 1 plus 3 equals 7. Steps for absolute values are isolate absolute value. Think of it as you're solving for it. And then you use reverse PEMDAS and inverse operations. So for example, in this case, get rid of the 3 and divide by 2. Okay, so think of the absolute value of x plus 1 as your variable that you're solving for and isolate it, just like you would solve for a variable. Okay, second step, and this is the part that is not the same as solving inequality, create 2 equations. 1 equals the negative, 1 equals the positive of what's on the right side, of right side. So in other words, this is how I typically do them. 1 creates, I'll do the positive first. 1 creates the positive. In other words, x plus 1 could be 2, in which case absolute value of 2 is 2. The other one creates the negative. In other words, x plus 1 could be negative 2 inside here, and the absolute value of negative 2 is also 2. Then solve each. So in this case, x equals negative 1. In this case, x equals negative 3. And final step, check. And this is extremely important in this case because often they don't all work, especially if there's a variable on the right at this step. Okay, so let me check them now. And check, here's the other part. Check in the original. This is the common error I saw on the homework. If you put negative 1 in here, oops, that should be 1. My bad. If you put 1 in here, you'll see it works. 1 plus 1 does equal 2. This is why you should check them, by the way, because you'll see things like that. You put negative 3 in here, and you'll see it'll work. But they'll both work here. What you want to check is that they work here. So let me do that. 2, 1 plus 1 plus 3 is 7. 2 times 2 plus 3 is 7. The other one, 2, negative 3 plus 1 plus 3 is 7. This is negative 2. Absolute value of negative 2 is positive 2, times 2 is 4, plus 3 is 7, and they both work. Now, most of the time they will work if there's just a number over here at this step, but if you do an equation with a variable over there, for example, like that, a couple things to watch out for. First of all, when you get to this step, x plus 1, one equation will look like that. The other equation, you make the whole thing negatives. In other words, you got to reverse the sign of that one as well. So that's one thing to watch out if you got variables over there. The second thing to watch out for is you absolutely have to check, because often only one of these will work. And again, check in the original, not in these. Okay, what I would suggest on this one is to write a problem down that is like that on the last homework. I'm not going to go through that with you, but just make sure you write one you know you have correct. Maybe one that I checked, for example, when I graded. Okay, next, absolute value inequalities. Let me give an example of that. So there are and inequalities and or inequalities with absolute values. They will automatically be compound. Here's an example of an and. Here's an example of an or. Now, how do I know which one's which? If this is less than, this is an and. Or less than or equal to. If it's greater, it's an or. And you'll see when you solve it how that'll work. Now, how do you solve these? You create two inequalities, one as written, and the other one with -2. And for an and, you just can put it over here and create one statement that has both of them in it. Make sure these are going in the same direction. And then I just solve in the same way that I would a compound inequality. And there we go, there's my answer. Now, if you haven't, this is pretty straightforward. Again, you put this in the middle, one right as it is, less than 2. The other one, put it on the other side, make it negative. Just think about the same thing you did with the equality, really. Just change the sign, and then solve. For the or, you actually have to create two separate ones, because they're not interlinked like this. One is as it's written, and this is the key place to watch for errors. The other one, you have to reverse it, but also you have to reverse the direction of the inequality. Reverse. Think of it as like multiplying by -1 or something. Okay. By the way, you did it actually here as well. It wasn't just as obvious because you just made it look like that. That looks like it's the same, but it actually says x plus 1 is greater than -2. Not x plus 1 is less than -2. So you did it in both cases. It's just this is where the error tends to occur. Okay, so now solve both. And yeah, there we go. Okay, I'm going to graph this one just because that's a little weird. I think this is an or, but it actually is an or with two parts because this is always going to be true. So or means that both of these, either one of them can be true. So I'm going to start with -3, and it's bigger than that. And this one has less than 1. Goes that way. Now this case, this is different than the ones I did before. It was usually the stuff in between. In this case, they overlap because this is true or this is true. They're not. It's not like the typical one, which is more like this. This is typical. Sometimes they'll overlap. This was my point before, which is that they're always the outside. By the way, if I made this, another example, if I made this +2, it would have been the outside. And in fact, let me do that example. You can pause this here at any point, by the way, if you want to write down this example. I'm just going to change the problem slightly to show you what is more typical. By the way, that worked because this is always true. An absolute value of something is always going to be bigger than -2. But let me try it with this problem. X plus 1 bigger than or equal to 2. X plus 1, again, reverse and negative. Just watch this. This is the, watch it. This gives me x bigger than 1. This gives me x less than -3. And now this looks like a more typical one. With two parts. There we go. And there's my solution with an or in between. So again, absolute value inequalities, they're either and or. They're and if they're less than, they're or if they're greater than. And this one create a compound, single compound inequality. This one create two separate ones. Solve them. This one will typically be between 2 points. Like so. This one will be typically outside, but watch out because this one can overlap and you can get all solutions, for example. All right, that's it. As I said, I would append this cheat sheet with anything you want, problems from your homeworks or review, or you can just use mine if you think you're fine on this stuff. Good luck tomorrow. Thanks.